Hello, people of the interwebs. Today we're going to be talking about loci or loci, or however you want to pronounce it. A locus is a set of points that satisfy a condition in geometry. So whether you're doing it in 1 dimension, 2 dimensions, or 3 dimensions, it always helps to think of it spatially. And you always have to think of all the possible ways that the point could be in a particular location. So let's start with 1 dimension on one line. Find this locus of points that are 1 centimeter away from this point. So that's pretty easy because you're limited to the number of points on this line. So let's just say this length is 1 centimeter, so there'd be 1 point right there and 1 point right there. And then you're done. So these 2 points make up the locus of points that are 1 centimeter away from this center point. And let's move on to 2 dimensions now. Find the locus of points that are 1 centimeter away from this point. So now you're not just limited to a single line, you have the entire two dimension x and y available to you. So it always helps to think of it as like this flat sheet of paper, for example. So now you have to think to yourself, what's the set of points that's going to be 1 centimeter away from this center point? Well, there would be this point right here. So this would be 1 centimeter. But there would be this point right here too, where that was 1 centimeter. And then if you were to think about it, then any point that was 1 centimeter away from this center point on a 2-dimensional plane would form a circle. That's a very badly drawn circle, but since the radius of the circle is 1 centimeter, then any point on this circle would be 1 centimeter away from the central point. So let's go on to a third question. Find the set of points that are 1 centimeter away from this given line. So distance, if you recall, from a point to a line is the shortest perpendicular distance. So you can pick any point on the line, let's say this point, and then the perpendicular of length 1 centimeter away would be this. But there is an infinite number of points on the line, so there would be an infinite number of perpendiculars, and there would be an infinite number of points on this end too. And then eventually you'd end up with one line parallel that's 1 centimeter away. But you have to remember that this is 2-dimensional, so it would be on this side too. Okay, let's move on to another one. Find the set of points that's equidistant from these 2 perpendicular lines. And the same thing applies the perpendicular distance. So let's just pick 1 point right here. So here, if you want to find the set of points that are equidistant from these 2 perpendicular lines, then that means that the perpendicular distance from this line to some point out here has to be equal to this perpendicular distance of any point on this line out here. And they have to intersect at a point. So you're essentially making a square, because this would be perpendicular, this would be perpendicular, so that last angle would have to be a 90-degree angle as well. And since these 2 are congruent, then those last 2 have to be congruent as well. So you're making something like this, where these 2 sides would be congruent, and this point of intersection would be on the line, because you could make an infinite number of these squares, and each of those would be part of the line that's equidistant from the 2 sides. So in the end, it would look something like this. And you would repeat that for the other side as well, because you could make squares like this so it would just end up with 2, and these 2 would be perpendicular as well. So you would end up with the locus that is equidistant from these 2 perpendicular lines is 2 new perpendicular lines. So let's move on to 3 dimensions now. In this question, we're to find the set of points that are 1 centimeter away from this center point in 3 dimensions. So when we're talking about 3 dimensions, I always find it helpful to think about a real-world object. So let's say that this tip of the Sharpie is that point right there. And if you were to think, then 1 centimeter away from this center point could be right here, or it could be right here, and it could be any number of points around, or any other way. So you'd realize that this is a sphere, because the radii would all be congruent. So this distance right here would be 1 centimeter. This distance right here would be 1 centimeter. And that's still just 2 dimensions, but you could also now go this way, out of the paper. So then this would be, so this side is coming out of the paper. So that would be 1 centimeter as well. And this side would be 1 centimeter. And this side, which is also coming out of the paper, would be 1 centimeter. So you would find that you have a sphere with a radius of 1 centimeter. So let's move on to the last one. It's a composite locus, and a composite locus means you're trying to satisfy 2 or more conditions instead of just 1. So here we're supposed to find the set of points that are 2 centimeters away from this center point, but they also have to lie on this plane. So the set of all points that would be 2 centimeters away from this center point would be a sphere, as we learned in number 5. So it would just be a sphere. Again, it's a badly drawn sphere because I can't draw circles. And it would have a radius of 2 centimeters. So now you have a sphere that's the set of points that are 2 centimeters away from this point, and that's satisfied one of the conditions. And now you have to satisfy the other condition, which is that it has to be on the plane. So now it's pretty obvious that the set of points that on the sphere that intersect the plane is that locus. Because each one of these points, so let's say that this part is where the sphere intersects the plane. So let's choose one point right here. This point right here would be 2 centimeters away from the center because that's a radius of the sphere, and it's also on the plane. And any one of these points right here on this disk, they're both on the plane and 2 centimeters away from that point. Hope you feel proud of yourself. Good luck on that test.